This is a video describing the RARS assembler. So unlike the Venus assembler, this is some type of program. It's not an online assembler. So it does a lot of amazing things, way more than I know. I know how to get what I want out of it, and that's what I want to show you today. So anyway, the link is on Canvas. I fired it up already. I wanted to get the size proper on this to make it work so that you could see it also. And so I had copied the program from the Venus assembler. So let's go ahead and do this. So if you look at it, it has two modes, edit and execute. So I'm going to be in edit mode, and I'm going to have to say it's not letting me do anything. So I'm going to have to say this is a new file, and I'm going to come down here, drop in that program, and I'm going to say file, save as, and I'm going to give it a name such as we use .s extensions for RISC-V programs, so I'm going to save it just as a .s file. It doesn't really matter what it is. So this is the program we were looking at before. It's all saved and ready to go, and we can look at this the way we looked at the other one. So most importantly here is I'm going to, up in this run, this run pull down menu, there's an assemble. Now I actually can't even remember this because I always use the F3 hotkey on this thing, and so that's what I'm going to do now. I'm use the F3 hotkey, which you can't see of course, but let's do it. Well, I won't. Let's just assemble it once like this. Okay, so once you assemble it, this is the result. Now, if you have a mistake in it, it's going to tell you it's not going to make it to the screen, or it might. I actually can't remember, but we'll go fix that. We'll go look at that when we're done. But once again, this is my source code here. This is the code that the assembler translates it to. So once again, a load immediate and J, those are pseudo instructions. So the J gets expanded to jump in link. Load immediate gets expanded to an add immediate. And so you'll see the instructions as the assembler in the form of base instructions here. This is what you wrote. This is the address, of course, and this address line, you can see it jumps by 4 every time. It starts at 0. And this is the machine code on this, and looks good. So I can do a couple things with this. I can the one I typically do here is step through it, and I can step thing. This is one step at a time. I know this button. So essentially it executed this instruction, which was to put a 5 into X10, and once I hit that, you can see the 5 went into X10, and it actually highlighted that line. It did it automatically. And so I'm going to clear X20. You're going to see X20 turn green like the other one did, which means it's executing that instruction. There it is, not too exciting. And so that's essentially it. And I can step through this thing, and it's making the jumps. You can see this X3 gets subtracted every time. Every time it changes the register, it tweaks. It turns out line green. So the other feature on this thing is the notion of a breakpoint. You can actually, if you don't want to spend time clicking the button, you can hit breakpoints on this. And then I'm going to hit the run key. So this is the run. What it's going to do is run until it hits the current breakpoint, which means it's going to jump back to here, jump back to the instruction, do blah, 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 and it's going to stop on this instruction. So there we go. So it stops on that instruction, and as I click this, you can see, we'll watch the X3 go down. Essentially, I'm going to click the run, and it's going to run to the breakpoint again. You can see this go down every time, etc., etc. So that's actually kind of good. Nice error messages down here. And this is actually the data segment, which we haven't talked about. No worries about that one, but I think that's about it. I'm actually sure you can go change memory values over here. Double click on it, put in anything I want in there, etc., etc., return. So I can change these on the fly as I'm testing them. Another very useful column here is is the labels that I use in the program. So loop, the number associated with the loop label is 8. Okay, so we'll check it out. The loop label has an instruction on it. That instruction lives at address 8, which is vitally important. The other important thing on the assembler is to get the machine code out of it. And the machine code is essentially, it's like the dump file. And I'm gonna hit this button right here, and it's gonna allow me to dump everything to the file. And so I'm gonna do hexadecimal format, and I only have a text segment, so everything's good here. I'm gonna dump it to a file. It wants a name. I mean, technically speaking, you can do this any way you want. I'm going to call otter_memory.mem, which is what we're going to use, what the memory wants, the memory model wants in Vivado, so I might as well save it at that now. Okay, so it's saved out into that file. I can go access that file later. And that's all I can think of with this. It's actually really quite a amazing assembler. Has a lot of options in it. We will be using more of them later, and that's okay for now. This is one of the things you kind of learn as you go along. I encourage people, when you got a few extra minutes, just to tweak through all the menus and get an idea of what it can do.